Hey everyone. I worked on a pretty interesting project the last couple months, and I thought the build process was worthy of capturing on video. The project involved building two scale model Ferrari F1 cars. Now you might be thinking, do I really want to sit here and watch a video of some guy just going out to a model store, buying a model kit, building and painting it? Well, that's actually not at all what I did, because these models were built entirely from scratch. I did this via 3D modeling, 3D printing, and a host of some other techniques. I went about doing this because scale model kits of F1 cars are actually pretty hard to come by. I think it's just because of all the expensive licensing that goes into all the logos that adorn these race cars. But if you do manage to find one, they're going to be very expensive. So if you buy it, your wallet's going to pay for it. Pun intended. So the first step was to find some decent 3D files, since I don't really think my CAD modeling skills are quite good enough to handle a project of this caliber. The Gearhead factory on Colts 3D has a nicely modeled 1/18 scale F175 designed for FDM 3D printing, which makes my life easier. The F175 is the F1 model Ferrari used in their 2022 race season. So it was recent enough that the design hasn't changed much between then and now. I purchased these files and got ready for printing. Since these were designed for FDM or filament 3D printing, it's really easy to set these up in the slicer and print them reliably. You don't always experience that when buying 3D files, so I really appreciate the Gearhead factory for considering the manufacturing process during the design phase. Nice work. And the link to their Colts page will be down in the description. I recommend checking out their page. It's got some pretty cool models on it. I printed the large parts in PLA at a 0.1 millimeter layer height on a Prusa i3 Mark III's Plus. I specify this because the smaller parts and parts with an ill-defined print orientation, like the suspension arms and outside mirrors, were printed in resin. The resin printer in question was a Form 4 from Formlabs. Man, say that 3 times fast. We have one in our office and it is awesome. I have to rely on it since I don't own my own resin printer. I'm just not really convinced on the safety aspects and reliability of the hobbyist machines. Now I'm still waiting and hoping that the resin printing space will have its bamboo moment, but until then, I'll stick with Formlabs. Here I captured some footage of the resin printing workflow since it's pretty unique compared to FDM. In the slicer, you don't have to rely on a flat face to orient your parts the same way you have to do with FDM printing. Instead, you just cant them at an oblique angle to reduce peel forces that could otherwise cause a print failure. Then you support them using these ultra minimalistic touch supports, and you just send the job to the printer. The printer uses UV light passed through an LCD screen to selectively cure a liquid acrylate photopolymer layer by layer, which it does extremely quickly and extremely accurately. After printing, you have to remove the parts from the build platform and wash off the uncured resin from the parts in isopropyl alcohol. Then you let them dry, which fortunately doesn't take too long thanks to IPA's volatility. And finally, just throw them into a UV curing oven to get them strong enough for use. Once complete, you just have to clip off the light touch supports, hit them with some sandpaper, and you're ready to rock. While all of this was printing, I had to make some design modifications to the Gearhead factory's wheel components since his original file didn't allow for the wheels to spin. First, I modified the wheel hubs in Blender to allow for an axle to be glued in. This was a bit challenging since the STL files for most of the wheel components were around 80 megabytes each, which means a little over 1,000,000 vertices for each part. That can be a bit hard to manage, but I got it done. Second, I remodeled the wheels themselves and wheel caps in Fusion 360 to accommodate the inclusion of the axle, which was also modeled in Fusion. I sent these off to the printer, but then I began to think about how to make the tires. I could easily just print these, but wouldn't it be cool if we could make actual rubber tires? I know you can use pliable materials in a 3D printer like TPU, but those just feel like flexible plastic. So while I was in Fusion, I drew up the tires to match those and the purchased files in order to create the cavity in a mold. The mold features keyways to align the two halves together, a pour spout, vent holes, and a slot in the side to wedge in a screwdriver to pry the halves apart. Like the wheel components, I sent the mold halves over to the printer. These were printed in the same PLA used for the F1 car and were printed at 0.1 millimeter layer height to minimize visible layer lines in the casted tire. While these were printing, I got looking for a suitable casting rubber. My go-to is Smooth On. I've been happy with their stuff in the past, plus we have a local distributor. I settled on Vitaflex 60 urethane rubber because 60A shore durometer is very similar to real tires and it has an ample working and cure time. Since Vitaflex 60 cures to an ivory color, I also bought some Uvo black pigment, which was a first for me. After printing, I removed the molds from the print bed and sprayed them with mold release, followed by a brush application to ensure everything was coated before giving them a final release coat. Then the halves were clamped together, placing the assembly on some tin foil to prevent leaks and spills. It was now time to prepare the urethane rubber, which simply involves pouring equal parts of A and B. This can be done by weight or volume. It doesn't have to be perfect since Smooth On is pretty forgiving with their formulations. I mixed together the two parts and weighed the final mix so I knew how much Uvo pigment to add because that is determined by weight only. Fortunately, you don't need to add much pigment because it is very concentrated and very opaque. I mean, look at how dark the mixture gets after only 4 drops. Using a syringe, I draw up and inject the black rubber mixture into the mold, overshooting through the vent holes to help pump air bubbles through the mold and out. I don't have a vacuum chamber which helps suck out air bubbles, but I do have a paint pressure chamber that's been repurposed for resin casting, which in some ways is better than a vacuum chamber. After sealing it up and adjusting the regulator, I pressurized it to about 55 psi. 16 hours later, it was time to demold. The tank holds pressure pretty well. It only drops a couple of psi during this long period. For the demold, I used a screwdriver to pry the two halves apart. If you're going to print your own molds, I highly recommend modeling in a slot for this very purpose. The tire was pried out enough so that the sprues could be clipped off along with any flashing. There are some very small pits from where bubbles were compressed down in the pressure tank, but it's totally passable. I ended up having to make 2 molds, one for the front wheels and one for the wider rear wheels. Lego, if you're watching, feel free to take notes.
The Lego one uses the exact same wheels and tires, front and rear, which it should not.
Because I have 2 F1 cars to make, I ended up with 8 wheels total. Now, I definitely had some failures along the way, and the tire's inner dimensions had to be adjusted a few times just so I got a firm enough seat around the wheel. But in the end, I got it done. At this point, minus the tires, these are all the parts I had to work with. My next steps were to prep the parts for painting. I hit some of the rougher areas with sandpaper and filled in some spots with Bondo glazing and spot putty because these spots either had the file creator's name engraved in a visible area or duplicated on adjacent parts, which I thought was a bit excessive. After letting this dry and sanding it down, which I didn't capture on video, I began hot gluing the parts to bamboo skewers, popsicle sticks, and toothpicks. This system works really well for me because I have a nice handhold while painting, and I can stick the parts into styrofoam blocks for drying. Simultaneously, I was assembling subcomponents together that would be painted the same color, such as the front wing and front wing end plates. For this specific subcomponent, I used Weld-On 3 because it does well to bond parts with small mating surfaces due to Weld-On 3 being a solvent weld. Otherwise, I just use Loctite liquid superglue. Over to painting, I used an airbrush primer for the first time. Vallejo black primer was perfect since much of the Ferrari F1 cars are black, so having the primer and top coat be the same color is a huge time save. Plus, Vallejo's primer is really nice quality and it dries really fast, which is a huge bonus over spraying with, say, Rust-Oleum primer, which seems to take about a week to cure. Priming is also really great at revealing surface imperfections, so after it fully dried, I went back in and sanded down noticeable lips, gaps, and layer lines. Back to the airbrush, it was time to apply the red top coat. Now, for those of you who are more familiar with color theory and may have done this a few times, you might be concerned about the success of applying a red top coat over a black undercoat. And you'd be 100% correct. Building opacity was a huge pain. Even after 8 coats of Vallejo Model Air Red, I could not achieve a vibrant red hue. So I had to essentially start over by applying a thin coat of Vallejo Model Air Light Gray over all the attempted red parts. With the delay in having to redo the red top coat, I decided to go back out and buy a different color of red for the top coat. And I ended up buying Vallejo's Model Air Ferrari Red. I mean, you can't get much better than that, right? Right. Well, it turns out Ferrari has 9 distinct reds available to customers today, and 15 over the course of the company's history. The red you imagine when you think of Ferrari is a very vibrant, almost cherry red. Vallejo's, on the other hand, features more orange and some brown, like tomato soup, according to one customer review. Well, due to my own color vision deficiencies, I felt like what I bought was exactly the right color. It wasn't until the model was nearly completed that I began to receive raised eyebrows, but more on that later. With painting finished, it was now time to begin final assembly. Gearhead Factory has easy to follow instructions on their YouTube channel, so I followed along with that to begin constructing the sub-assemblies. After completing the back half, I wanted to insert some weights into the body hollow. Weighted models feel really nice in the hand and give the impression of a high quality product. Lord knows that after that snafu with the paint selection, I need all the help I can get. Joking aside, a quarter and a handful of pennies were hot glued to the inside of the body and floor, focusing the weight behind the driver and around the location of the engine on the actual race car to give the finished product a solid weight balance. With that complete, the rear half was glued to the front half, marking the completion of the main body. Next, the front suspension components were glued in place. I've always looked at these linkages on F1 cars, wondering where one ends and the other begins. It's kind of a tangle at first glance, but this model helped cement, pun intended, where everything goes and how it all functions. I also glued the front wings in place, which required some rework to the nose to get everything to mate well together, but with it on, it's really starting to look like an F1 car. The rear suspension components were added next. It's cool to see the differences between the designs of the front and rear drivetrain here. Oh, and I left the wheel hubs partially painted since they'll be hidden, plus paint will only hinder a smooth rotation. At this point, I threw on the wheels to give it a roll test, and everything functioned as expected. Next, I added the onboard cameras, steering wheel components, and got the halo prepped and ready. And here's what the cars were looking like up to this point. I think the only thing I had missing was the pitot and antenna, both of which go on the front nose, but mostly everything else is here. Now, because of some light warping on the floor pieces and mild assembly variation, I had a gap between the front and rear floor that required filling in. I used Milliput for the first time to accomplish this. Seems like the online model building community uses it a lot. I also added some to the wingtip. This is one of those steps that makes me realize I need to do a little bit better job planning the assembly prior to painting. Because now I was in a situation where I had to sand the dried Milliput down and then repaint the sanded areas. I swear I had to get my airbrush out like 8 times during this whole project, which probably could have been cut down by half or maybe even more if I just planned ahead a little bit better. Thankfully, airbrushing is great for getting out of a tight spot, or rather painting into one. By setting the pressure low, I can very carefully spray in confined areas without having to mask, which is a huge reason why I ended up getting an airbrush. The gap is now gone, and honestly, hardly looks like it was ever even there. While I was in paint mode, I added some red paint to represent the blinking red taillight. I painted the outside mirror glass silver, and painted the yellow circles around the center of the hubcaps, along with the silver tip at the center. Yellow paint was also added to the front edge of the front wheel flow deflectors. So here are the 2 F1 cars and the wheel components up to this point. I hadn't assembled the wheels fully because my next step was gloss clear coating, although the hubcaps would also receive a gloss coat. I applied 2 coats and let them cure for a little over a day. Race car models are a little bit easy this way because the gloss coat both provides a nice shiny finish and it also allows for easy decal application. And speaking of decals, I needed them. A lot of them. I couldn't find any pre-existing decals for this model, let alone at this scale, most likely due to the logo licensing issues I mentioned at the beginning of the video. So I had to make my own. I purchased some white-backed inkjet water slide decal paper, since so many of the decals have white lettering. I started by noting all the decals I would need to create by studying the F-175 from a few angles. Then I used calipers to determine the size needed for each one. In Word, I loaded all the logos in, added the color-matched red or black backings, and sized them based on my notes. Once printed, I coated them with a couple coats of gloss clear coat to seal them in, and I let them cure overnight. And this is how they looked after all this. Look pretty great. Now, for the decal application, I didn't capture any video of this process, but I did manage to nab a few shots along the way. Things were chugging along pretty nicely, although I wasn't super happy with the quality of the decal paper because the gloss coat tended to delaminate as my X-Acto blade was cutting out a decal. So I had to limit the water exposure time to prevent the decals from bleeding. I didn't have these issues with another brand of decal paper that was clear backed, so I think it's just the specific paper and not the gloss coat. Plus, the white back decal paper tended to show some white edges where I had cut. The good thing is that when you end up holding the car from about like a foot away, comfortable viewing distance, everything looks super awesome. I guess you could make the same complaint about seeing some layer lines on the body parts if you look close enough too. All in all, I was getting really excited seeing this model look more and more like the real thing. With all the decals applied on both models, I sealed them in with another gloss coat. After drying, it was finally time to assemble some wheels. The system I custom designed worked out well, although if I had more control over the design from the start, I would have incorporated bearings. And here are some shots of the completed build. Going back to the red color, thanks to the theory behind color harmony, the type of red we see on the actual F-175 is heavily dependent on lighting. In some photos, the red is more vibrant cherry, and in others, it more closely resembles the Vallejo Ferrari red I used. I was grateful for this because it was not until all the gloss coats had been applied that I started receiving criticism on the color, so fixing it at that point would have been a huge pain. Either way, it's unmistakable which team is represented here. The final step of this project was to ship these models out since they were Christmas gifts. Anyone who's ever had to move with models or ship a model knows that models don't really survive transit all that well. Therefore, this step was arguably the most important step of the entire project. I purchased a sturdy Easy brand Tupperware and 2 paint sticks from Home Depot. I cut holes in the sides of the Tupperware to allow for the paint sticks to slide through and hot glued them into place. The F1 cars would sit on these paint sticks, essentially floating in midair to minimize the risk of any delicate parts from breaking off due to pressure or from getting knocked about. I cut notches into the paint sticks for twine to mate into, the twine serving as the bracing that holds the F1 car securely in place. I even learned a bushcraft knot to firmly secure the twine without needing more than 2 hands. With the packaging complete, it was time to get it into a cardboard box. I have loads of spare foam lying around my office from Pelican cases and buying various equipment. The joke with my colleagues is that I use it as a bed when siesta time kicks in. But it comes in handy for stuff like this. I was very, very liberal with lining the box with this foam and some air packs I had lying about. At this point, I was so confident this would survive shipping, I began to wonder how it would fare being dropped from the roof of our 3-story building. Anyways, that's the whole project. I learned a lot on this build, as I seem to do with every scale model project I take on, and I definitely acquired some new skills that I'm looking forward to applying in the future. And on that note, stay tuned for more. Bye for now.